The world of construction is undergoing a massive transformation. With every new technological advancement, the way we build is becoming faster, smarter, and more sustainable. From 3D printed buildings to AI-powered safety systems, the industry is embracing innovations that are reshaping how we think about construction. In this video, we'll dive into construction technologies that have reached a whole new level, driving efficiency, safety, and sustainability to new heights. Let's take a look at how these game-changing technologies are building the future, one project at a time. 1. Building Information Modeling. What do you say? Building Information Modeling, BIM, is a transformative technology that provides a three-dimensional digital model of a building. This tool enhances collaboration between architects, engineers, and contractors by allowing them to work together in a shared digital space. BIM helps identify design flaws early, streamlines the construction process, and ensures that every detail is carefully planned. It reduces errors, minimizes waste, and ensures that everyone involved in the project is on the same page, making it a game changer in modern construction. 2. AI-driven project management. AI-driven project management tools leverage big data and machine learning to predict potential risks, schedule delays, and budget overruns before they happen. By analyzing past project data, AI systems provide real-time insights that help construction teams make informed decisions, manage resources more effectively, and avoid costly mistakes. This technology improves project efficiency by identifying patterns and automating tasks, ensuring projects stay on track and within budget. 3rd, augmented reality. Augmented reality, AR, overlays digital images onto the real-world environment, allowing construction teams to view 3D models in real time. With AR, workers can visualize design plans overlaid on actual construction sites, helping ensure systems like plumbing and electrical wiring are installed correctly. This technology reduces mistakes, enhances accuracy, and saves time by enabling teams to confirm placement and dimensions before any physical work is done. AR is a powerful tool for collaboration and problem solving in construction. 4th, virtual reality. Virtual reality, VR technology, allows stakeholders to walk through a building before construction starts. This immersive 3D experience helps architects, designers, and clients visualize the final product, explore different layouts, and make design adjustments in real time. VR provides valuable insight into space usage, lighting, and design flow, preventing costly changes during construction. It's also a powerful tool for client presentations, enabling an engaging and realistic preview of the building. 5th, generative design. Generative design uses AI to create multiple design options based on specific input parameters like materials, spatial constraints, and environmental factors. By inputting goals such as maximizing energy efficiency or minimizing waste, designers can explore countless design possibilities that might not have been considered through traditional methods. This approach leads to more optimized, sustainable, and efficient buildings as it incorporates performance, material, and cost considerations from the outset. 6. Cloud-based project management. Cloud-based project management platforms offer real-time updates and allow construction teams to access documents, drawings, and schedules from anywhere. These tools improve collaboration by ensuring everyone is working from the most up-to-date information, regardless of location. Cloud-based platforms make communication more efficient. 7. 3D printing of buildings. 3D printing has revolutionized construction by enabling entire buildings to be printed layer by layer using materials such as concrete, steel, and composites. This method dramatically reduces construction time, cuts labor costs, and minimizes material waste. 3D printing also opens up new design possibilities by allowing complex custom shapes that would be difficult or impossible to create with traditional methods. This technology is paving the way for faster, more sustainable, and cost-effective construction projects. 8. Modular construction. Modular construction involves the prefabrication of building units in a controlled factory environment before they are transported and assembled on site. This process cuts down on construction time, reduces material waste, and ensures higher quality control. By building off-site, modular construction minimizes disruptions at the construction site and can significantly reduce labor costs. This approach is particularly useful for projects that need to be completed quickly, such as affordable housing or temporary structures. 9. Robotic bricklaying. Robotic bricklaying technology automates the process of laying bricks with impressive speed and precision. Machines like SAM, semi-automated mason, can lay thousands of bricks in a day, increasing productivity and consistency. These robots reduce labor costs and improve accuracy by eliminating human error. Robotic bricklaying is also beneficial for reducing physical strain on workers, allowing them to focus on more complex tasks while robots handle the repetitive work. 10. Self-driving construction. Self-driving construction vehicles like bulldozers and excavators are transforming job sites. These autonomous machines can operate continuously, improving efficiency and safety by reducing the risk of human error. With sensors and cameras to detect obstacles and adjust their path, these machines are capable of operating in hazardous or hard-to-reach areas, ensuring faster project completion while lowering labor costs and minimizing safety risks. 11. Exoskeletons. Exoskeletons are wearable suits designed to assist construction workers with heavy lifting and reduce physical strain on their bodies. These devices provide support to the user's joints and muscles, helping to prevent injuries and fatigue. By enabling workers to handle heavier loads more safely, exoskeletons improve productivity and reduce the likelihood of workplace injuries, making construction jobs safer and less physically demanding. 12. Drones for aerial surveying. Drones are increasingly being used in construction to capture high-resolution aerial images, create 3D site models, and monitor progress. Drones can survey large areas quickly and efficiently, providing teams with real-time updates on the status of a project. They can also be used for inspections, helping to identify potential issues that may be difficult to detect from the ground. Drones improve accuracy, reduce labor costs, and enhance safety by minimizing the need for workers to perform dangerous manual surveys. 13. Robotic welding. Robotic welding automates the welding process, offering faster, more consistent results compared to human welders. These robots can work in extreme conditions, such as high altitudes or dangerous environments, ensuring quality and safety. Automated welding also improves precision, reduces waste, and increases the overall speed of construction. Robotic welding systems help reduce labor costs and are particularly useful for projects that require large amounts of welding, such as steel structures. 14. Laser scanning. Laser scanning technology captures high-accuracy 3D data of a construction site. This data is used to create precise digital models of the space, helping architects and engineers detect discrepancies, measure structures, and assess the site's progress. Laser scanning ensures that every element is in the correct place and helps teams make real-time adjustments. It is especially useful for renovation projects, where existing structures need to be scanned and integrated into new designs. 15th. Augmented worker training. Augmented reality, AR, is now being used to train construction workers in virtual environments that simulate real-world tasks. These AR-based training programs help workers learn how to operate machinery, handle materials, and adhere to safety protocols in a risk-free setting. By providing realistic simulations, AR reduces training time, improves retention, and ensures that workers are fully prepared to perform their jobs safely on the actual site. 16. Green roofs. Green roofs are covered with vegetation, providing natural insulation, managing stormwater, and reducing the urban heat island effect. They improve air quality, enhance biodiversity, and offer a sustainable way to manage building energy needs while beautifying the urban landscape. 17. Energy-efficient windows. Energy-efficient windows adjust their tint in response to sunlight, helping to regulate the building's internal temperature. This reduces the need for artificial heating and cooling, which lowers energy costs and enhances the building's overall efficiency. 18. Self-healing concrete. Self-healing concrete contains bacteria that produce limestone to seal cracks automatically. This prolongs the life of concrete structures, reducing the need for repairs and improving the durability of buildings while decreasing maintenance costs. 19. Recycled construction materials. Recycling materials like steel, glass, and plastics reduces the demand for new raw materials, conserves energy, and reduces waste. Using recycled construction materials minimizes the environmental impact of construction and promotes sustainability in the industry. 20. Solar panels integrated into building materials. Solar panels are now integrated into building materials like roofing tiles and windows. These materials allow buildings to generate renewable energy on site, reducing reliance on grid electricity and decreasing utility costs for building owners. 21st, biodegradable construction materials. Biodegradable materials like mycelium-based bricks break down naturally and pose less environmental risk. These materials are ideal for temporary structures or projects that prioritize sustainability, reducing the overall carbon footprint of construction. 22. Energy-efficient insulation. Advanced insulation materials improve the thermal efficiency of buildings, keeping them cooler in summer and warmer in winter. These materials help reduce the need for heating and cooling systems, cutting energy consumption and providing long-term cost savings. 23rd, geothermal energy systems. Geothermal systems use the Earth's constant temperature to heat and cool buildings. This renewable energy source is highly efficient and sustainable, offering cost-effective heating and cooling solutions that reduce dependence on fossil fuels. 24. Wind turbines. Small wind turbines integrated into building designs help generate on-site renewable energy. These turbines reduce the building's reliance on the grid and lower energy costs while contributing to the building's overall sustainability. 25. Water recycling systems. Water recycling systems capture and reuse water on site for tasks like mixing concrete or irrigation. By recycling water, construction sites can reduce their water consumption and lower costs, all while minimizing the environmental impact of the project. 26. Bio-based building materials. For decades, construction has relied on concrete, steel, and bricks materials that require massive energy consumption and contribute heavily to carbon emissions. But what if buildings could be made from materials that grow naturally, were biodegradable, and even help the environment? Enter bio-based building materials, a revolutionary step toward eco-friendly construction. One of the most fascinating examples of this is mycelium, the root-like structure of fungi. Mycelium-based bricks are lightweight, fire-resistant, and stronger than concrete, all while being made from natural, renewable resources. These materials literally grow into shape, meaning they require zero industrial processing. When their lifespan is over, they can be composted instead of demolished, reducing construction waste significantly. Another bio-based innovation is algae-powered facades. These living walls contain microalgae that absorb CO2 and generate biofuel while also providing insulation. In cities struggling with air pollution, these facades could be a game changer, actively cleaning the air while producing clean energy. Bamboo is another material making a comeback. Known for its incredible strength-to-weight ratio, bamboo grows up to 35 times faster than traditional trees, making it one of the most sustainable alternatives to conventional wood. Modern bamboo reinforced concrete is being used in bridges and buildings, offering an eco-friendly and cost-effective replacement for steel reinforcement. With climate change and urban expansion pushing the limits of our resources, bio-based materials are proving that nature and technology can work together to create a greener, more sustainable future for construction. 27th, prefabricated construction. For most of modern history, constructing a building meant starting from scratch on-site brick by brick, beam by beam. But with the rise of prefabrication, entire sections of buildings are now manufactured in a factory, transported, and then assembled on-site like Lego blocks. This approach is faster, cheaper, and more precise than traditional methods, making it the go-to solution for high-demand urban housing and large-scale infrastructure projects. The best part, prefabrication isn't limited to simple box-like structures anymore. With advancements in design and materials, even luxury skyscrapers and high-end hotels are now being built using modular components. For example, the world's tallest modular hotel, the Citizen M Bowery Hotel in New York, was built in just 21 months, while a similar-sized traditional hotel would have taken nearly double the time. One of the biggest advantages of prefabrication is quality control. Since everything is built in a controlled factory environment, there's no risk of weather delays, inconsistent workmanship, or last-minute design changes. Every unit is checked and tested before being transported to the construction site, ensuring perfect fit and finish. And then there's sustainability. Because components are produced with exact measurements, there's less material waste, and factory conditions allow for better recycling and reuse of leftover materials. Plus, modular buildings can often be disassembled and relocated, reducing demolition waste. Countries like China and Sweden are leading the way in prefabricated skyscrapers, with entire apartment complexes being built in just a matter of weeks. Meanwhile, companies in the US and UK are using modular construction to tackle affordable housing shortages, producing high-quality, low-cost homes in record time. 28. Floating cities. With sea levels rising every year, some of the world's biggest cities like New York, Miami, and Tokyo are at serious risk of flooding. So what's the solution? Build cities that float. Sounds crazy, but floating cities are already being developed, and they might just be the future of urban living. The idea behind floating cities is simple. Instead of building on land that could be underwater in a few decades, we construct entire communities on floating platforms. These platforms, made from reinforced concrete, buoyant materials, and self-sustaining ecosystems, are designed to rise and fall with the ocean, making them flood-proof. One of the most ambitious projects is Oceanic City, a UN-backed initiative that aims to build a fully self-sufficient floating city in the next few years. Designed by Bjarke Ingels Group, this futuristic city will feature modular floating platforms that can be expanded as needed. The city will run on renewable energy, solar, wind, and wave power, recycle all waste and water, and even grow its own food using vertical farming and aquaponics. 29th, smart roads. Imagine driving down a highway that automatically charges your electric vehicle, detects icy conditions before you even realize it, and warns you about upcoming accidents in real time. Sounds futuristic, right? Well, smart roads are already making this a reality. These next-gen roads are built with embedded sensors, solar panels, and wireless charging technology, completely changing how we interact with transportation infrastructure. One of the most revolutionary features, wireless EV charging lanes. These roads use inductive charging technology, meaning electric cars can recharge their batteries just by driving over them, no need to stop at a charging station. Countries like Sweden and the UK are already testing these highways, and if widely implemented, they could eliminate range anxiety for EV owners altogether. But that's not all. Smart roads are also packed with intelligent traffic management systems. Using AI-powered sensors and cameras, they can detect traffic congestion, accidents, or hazardous conditions and send instant updates to drivers, helping prevent crashes and reduce bottleneck. 30. AI-powered construction robots. If you think robots are just for factories and sci-fi movies, think again, bro. The construction industry is now deploying AI-powered robots that can lay bricks, install drywall, and even 3D print entire buildings without breaking a sweat. These bots are making construction faster, safer, and way more efficient. Take Hadrian 10, for example. This robotic bricklayer, developed by an Australian company, can lay 1,000 bricks per hour, something that would take a human worker an entire day to accomplish. The robot uses advanced AI and laser-guided precision to place each brick perfectly, ensuring no errors and minimal waste. But it's not just about bricklaying. Autonomous excavators and bulldozers are already being used on construction sites. These machines use GPS, sensors, and AI to dig trenches, move earth, and clear land without human intervention. Companies like Caterpillar and Komatsu are rolling out self-driving construction vehicles that can work 24/7, eliminating delays and reducing labor costs. And then there's robotic drywall installation. In Japan, companies are using humanoid robots that can lift and attach drywall panels with precision. These robots reduce worker fatigue and injuries while improving efficiency. One of the biggest advantages of AI-powered robots is safety. The construction industry is one of the most dangerous fields to work in, with thousands of accidents happening every year. By automating high-risk tasks like working at extreme heights or handling heavy materials, robots help prevent injuries and fatalities on job sites. As we've seen, the construction industry is evolving rapidly, driven by innovations that are making buildings smarter, safer, and more sustainable. From AI and robotics to advanced materials and energy-efficient systems, these technologies are revolutionizing the way we design, build, and live. The future of construction is not just about taller buildings or faster projects, it's about creating environments that are better for people and the planet. If you enjoyed this look at the future of construction, don't forget to like, comment, and share this video. And of course, hit that subscribe button and press the bell icon so you never miss out on more exciting insights.